Hi friends, today we are going to discuss about Newton's divide difference interpolation formula. Newton's interpolation formula developed in the earlier sections can be used only when the value of the independent variable x are equally spaced. Also, the difference of the y must be ultimately become small. If the value of the independent variable are not given at equidistant interval, the following two interpolation formulas are used. The first one is the Lagrangian interpolation formula and the second one is the Newton's divide difference interpolation formula. So in this video we are going to discuss about Newton's divide difference interpolation formula. Let y equal to f of x be a function which takes value y0, y1, y2, etc. yn corresponds to the value of x0, x1, x2, etc. xn. Then the first divide difference f of x comma x0 can be written as f of x minus f of x0 divided by x minus x0. From this we can write f of x is equal to f of x0 plus f of x comma x0 into x minus x0. This is our equation number 1. Then also by second divide difference f of x comma x0 comma x1 is equal to f of x comma x0 minus f of x0 comma x1 divided by x minus x1. From this we can write f of x comma x0 is equal to f of x0 comma x1 plus x minus x1 into f of x comma x0 comma x1. This is our equation number 2. Then using equation 2 in 1 we get f of x is equal to f of x0 plus x minus x0. Instead of f of x comma x0 we can write equation 2, that is f of x0 comma x1 plus x minus x1 into f of x comma x0 comma x1. That's equal to f of x0 plus we can multiply x minus x0 into all the other terms, that is x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x comma x0 comma x1. Then by the third divide difference f of x comma x0 comma x1 comma x2 can be written as f of x comma x0 comma x1 comma x2 is equal to f of x comma x0 comma x1 minus f of x0 comma x1 comma x2 divided by x minus x2. From this f of x comma x0 comma x1 is equal to f of x0 comma x1 comma x2 plus x minus x2 into f of x comma x0 comma x1 comma x2. This is our equation number 4. Now this is our equation number 3, that is f of x is equal to f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x comma x0 comma x1. Now instead of this f of x comma x0 comma x1 we can substitute equation number 4. So substituting equation 4 into 3, we get f of x is equal to f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x0 comma x1 comma x2 plus x minus x2 into f of x comma x0 comma x1 comma x2. That is f of x is equal to f of x0 plus x minus x0 f of x0 comma x1 plus x minus x0 into x minus x1 into f of x0 comma x1 comma x2 plus x minus x0 into x minus x1 into x minus x2 into f of x comma x0 comma x1 comma x2. Now continuing like this, we can write f of x is equal to f of x0 plus x minus x0 into f of x0 comma x1 plus x minus x0 into x minus x1 into f of x0 comma x1 comma x2 plus x minus x0 into x minus x1 into x minus x2 into f of x comma x0 comma x1 comma x2 plus etc. plus x minus x0 into x minus x1 into etc. x minus xn minus 1 into f of x comma x0 comma x1 comma up to xn minus 1 plus x minus x0 into x minus x1 into etc. x minus x n into f of x minus x0 f of x comma x0 comma x1 comma f of xn. Also, as f of x is a polynomial of degree n, therefore the n plus 1th and the higher divide differences are 0. That is, therefore f of x comma x0 comma x1 comma etc. xn is equal to 0, so that the last term will be 0. So this is called the equation number 5. So we can write equation number 5 as, equation 5 can be written as f of x is equal to f of x0 plus x minus x0 delta f of x0 plus x minus x0 into x minus x1 into delta square f of x0 plus etc. x minus x0 into x minus x1 into etc. x minus x n minus 1 into delta raised to n f of x0. This is called the Newton's formula for an unequal interval, or Newton's divide difference formula. Newton's divide difference interpolation formula, f of x is equal to f of x0 plus x minus x0 delta f of x0 plus x minus x0 into x minus x1 into delta square f of x0 plus etc. plus x minus x0 into x minus x1 into x minus x2 into etc. x minus xn minus 1 into delta raised to f of x0. The Newton's divide difference interpolation formula can also be expressed in terms of forward, backward and central differences. That is, the delta f of x0 which is equal to y of x0 comma x1, which can be expressed as y1 minus y0 divided by x1 minus x0. We know that y1 minus y0 is delta y0. Also, x1 minus x0 is h. So, we know that the Newton's divide difference interpolation formula is expressed in terms of Newton's forward difference formula. Also, y of x0 comma x1 comma x2 is equal to y of x1 comma x2 into minus y of x0 comma x1 divided by x2 minus x0, which can be expressed as y of x1 comma x2 can be expressed as delta y1 divided by h minus y of x0 comma x1 can be expressed as delta y0 divided by h, which is equal to delta square y0 divided by 2 factorial h square. That is, y of x0 comma x1 comma x2 is equal to delta square of y0 divided by 2 factorial into h square. So, the Newton's divide interpolation formula is expressed in terms of Newton's forward difference formula. The Newton's divide difference interpolation formula is expressed in terms of Newton's forward difference. So, this can be written in general. It is y of x0 comma x1 etc. xn can be written as delta raised to n y0 divided by n factorial h raised to n. So, the Newton's divide interpolation formula is expressed in terms of Newton's forward difference formula. Similarly, we can write the Newton's divide interpolation formula in terms of Newton's backward interpolation. That is, comma x1 that is equal to y1 minus y0 divided by x1 minus x0, that is by first divide difference, that is equal to nebula y1 divided by h1 minus h0 is h. Also, we can write that y of x0 comma x1 comma x2 is equal to y of, by second divide difference, by y of x1 comma x2 minus y of x0 comma x1 divided by x2 minus x0, that is equal to nebula y2 divided by h minus nebula y1 divided by h, the whole h2 minus x0 is 2h, that is equal to nebula square y2 divided by 2 factorial h raised h square. So, we can see that the Newton's divide difference interpolation formula is expressed in terms of Newton backward difference formula. So, this can be in generally we can write that in general y of x0 comma x1 etc. xn is equal to nebula raised to n yn divided by n factorial h raised to n. So, in terms of center differences, y of x0 comma x1 is equal to y1 minus y0 divided by x1 minus x0, which can be written as small delta y of half divided by h. That is, the Newton's divide interpolation formula is expressed in terms of central differences. Similarly, we can write y of x0 comma x1 comma x2 is equal to y of x1 comma x2 minus y of x0 comma x1 divided by x2 minus x0, which is equal to small delta y of 3 by 2 divided by h minus delta y of 1 by 2 divided by h the whole divided by 2h, that is small delta square of y1 divided by 2 factorial into h square. So in general we can write that y of x0 comma x1 etc x of 2n, which is equal to delta of 2m into ym divided by 2m factorial h raised to 2m. So the Newton's divide difference interpolation formula is expressed in terms of Newton's backward and forward and central differences. Now we can discuss a problem. The following values of a function f of x for values of x are given, that is f of 4 is equal to 48, f of 5 is equal to 100, f of 7 is equal to 294, f of 10 is 900, f of 11 is 1210, f of 13 is 2028. Find f of 18 and f of 15. For solving the problems, now we can find the divide difference table, or we can check how to form a divide difference table. First of all, we can write the x values, that is x0, x1, x2, x3, x4, corresponding f of x, that is f of x0, f of x1, x2, x3, x4. This is the first divide difference, that is delta f of x. The first divide difference delta f of x can be written as f of x0 comma x1, that is f of x0 comma x1. This is the first divide difference, that is equal to f of x1 minus f of x0 divided by x1 minus x0. This is the first divide difference. Similarly, we can write that is f of x1 comma x2, that is equal to f of x2 minus f of x1 divided by x2 minus x1. Also, f of x2 comma x3 can be written as f of x3 minus f of x2 divided by x3 minus x2, and f of x3 comma x4 is equal to f of x4 minus f of x3 divided by x4 minus x3. This is the first divide difference. Then delta square f of x is the second divide difference, which is equal to f of x0 comma x1 comma x2, that is equal to f of x1 comma f of x2 minus f of x0 comma x1 divided by x2 minus x0. That is, the second divide difference is the difference between the first divide difference, that is f of x0 comma x1 comma x2 is equal to f of x1 comma x2 minus f of x0 comma x1 divided by x2 minus x0. Also, f of x1 comma x2 comma x3 is equal to f of x2 comma x3 minus f of x1 comma x2 divided by x3 minus x1. Similarly, f of x2 comma x3 comma x4 is equal to f of x3 comma x4 minus f of x2 comma x3 divided by x4 minus x2. Then the third divide difference delta cube of f of x is equal to, which is the difference between the second divide difference, that is f of x0 comma x1 comma x2 comma x3, that is equal to f of x1 comma x2 comma x3 minus f of x0 comma x1 comma x2 divided by x3 minus x0, x3 minus x0. Then f of x0 comma x1 comma x2 comma f of x1 comma x2 comma x3 comma x4 is equal to f of x2 comma x3 comma x4 minus f of x1 comma x2 comma x3 divided by x4 minus x1. This is the divide difference table. So, in order to solve this problem, first of all, we have to construct the divide difference table. The first column, we can write the value of the variable x. Then, the corresponding, the value of the function f of x can be written in the second column, the value of the f of x. So, in this case, the value of the x can be written as 4, 5, 7, 10, 11 and 30. Corresponding the value of the function f of x is 48, 100, 294, 900, 1210, 2028. So, from this we can construct the first divide difference delta f of x. We know the equation for the first divide difference f of x is equal to so this is the value of x0, x1, x2, x3, x4 and x5. So the delta f of x, the equation for the delta f of x is equal to f of x1 minus f of x0 divided by x1 minus x0. That is 100 minus 48 divided by 1. That is equal to 52. So then next the value of delta f of x2, that is 294 minus 100 divided by 7 minus 5, that is 97. Similarly, we can write that these are the value of the first divide difference. Then by second divide difference, delta square of f of x can be written as then the second divide difference delta square f of x, that is f of x0 comma x1 comma x2 is equal to f of x1 minus x2 minus f of x0 comma x1 divided by x2 minus x0, that is delta square of f of x is equal to 97 minus 52 divided by 7 x2 minus x0, that is 7 minus 4, that is equal to 15. Similarly, we can write that delta square of f of x2, that is equal to 202 minus 97, 202 minus 97 divided by 10 minus 5, that is equal to 21. Then next delta square of f of x3 is equal to 310 minus 202 divided by 11 minus 7, that is equal to 27. Then delta square of f of x of x4 is equal to 409 minus 310 divided by 30 minus 10, that is equal to 33. Now delta cube of f of x is equal to delta cube of f of x is equal to here 21 minus 15 divided by 10 minus 4, that is equal to 6 by 6 equal to 1. Also delta square f of x of x2 is equal to 27 minus 21 divided by 11 minus 5, that is also equal to 1. Also delta square f of x of x3, that is 33 minus 27 divided by 30 minus 7, that is equal to 1. So delta 4 of f of x is equal to minus 1, that is 0, 0. So this is our divide difference stable for this problem. The Newton's divide difference interpolation formula can be written as f of x is equal to f of x0 plus x minus x0 into delta f of x0 plus x minus x0 into x minus x1 into delta square f of x plus x minus x0 into x minus x1 into x minus x2 into delta cube f of x0 plus etc. So we can substitute the values, that is equal to f of x is equal to f of x0. x0, the value of x0 is 4, that is f of 4 plus the value of x is x0 is 4, that is x minus 4 into delta f of 4 plus x minus 4 into x minus the value of x1 is 5, x minus 5 into delta square of f of 4 plus x minus 4 into x minus 5 into x minus 7, the value of x2 is 7, x minus 7 into delta cube of f of 4 plus etc. That is equal to the value of f of 4. From the question, it's clear that the value of f of 4 is 48. That is 48 plus x minus 4 into delta f of 4. The value of delta f of 4 is 52. That is 52 plus x minus 4 into x minus 5 into, then delta square of f of 4 is 15. That is 15 plus x minus 4 into x minus 5 into x minus 7 into, and the value of delta cube of f of x, that is delta cube of f of 4 is 1. Similarly, f of 8. So we have to find f of 8 and f of 15. So f of 8 is equal to, instead of x we can substitute 8. That is 48 plus 8 minus 4 into 52 plus 8 minus 4 into 8 minus 5 into 15 plus 8 minus 4 into 8 minus 5 into 8 minus 7. That is equal to 48 plus 4 into 52 plus 4 into 3 into 15 plus 4 into 3 into 1. That is equal to 448. So f of 8 is equal to 448. Similarly, we can find the value of f of 15. Instead of x, we can substitute 15. So f of 15 is equal to 48 plus 15 minus 4 into 52 plus 15 minus 4 into 15 minus 5 into 15 plus 15 minus 4 into 15 minus 5 into 15 minus 7 into 1. That's equal to 48 plus 11 into 52 plus 11 into 10 into 15 plus 11 into 10 into 8. That is equal to 2743. This is the value of f of